In the previous lesson, you added the leveldata.json to the data folder from the resources attached, hopefully anyway, to the lesson itself. That contains all of the JSON data that we're going to use to build up our level. Now, we've already earlier on in the course looked at JSON, but just as a quick refresher, just in case you've forgotten what it is, it's a key value store like a dictionary. So it's basically a text format of keys and values. It's usually the format these days that's used to exchange data between applications. There used to be something called XML. There still is something called XML. That's really verbose in comparison. This is much, much smaller and more efficient. The great thing about JSON is it's so common that every programming language pretty much now can read it in and process it and have it then inside their internal store. In case all that's a little bit confusing, I've actually put a little example on here of a typical use. This is the Google Maps API, where you usually have an API key. You visit then a particular URL and you get back this, which is a JSON object in this case. The curly braces we see indicate an object, think dictionary in terms of C#. Then the square braces here indicate a list, also similar to in C#. So when you go to the Maps API with Google, you get some JSON back. It's literally text. You can open it and read it with a text file. It starts here with an object which has a key markers. So if you get the value for the key markers, that's in a list with all of these markers on. And they are then objects themselves, which have then keys and values as well. And when I say object, I mean in terms of C#. Dictionary here. So in terms of the level data JSON that we've got, it looks a little bit like this. So I put this into a JSON formatting website just so it spreads it all out nicely, because the one you have is all on one line to make it small. And what we basically have is we have an object all the way up here, and then we have a key for each of the levels. So if we select level 1, what we'll be doing is getting this object here as the value back. So the value that comes back has a few keys as well. It has a key tiles, and then it has a key player start. For the player start, you can see the value is another object which has a key X and a key Y, and that's actually the tile coordinate where the player starts. We'll come to that a bit later. If you get the value under the key tiles, there you've got an object and you've got some keys as well, where you'll have the floor, the walls, the targets, the target boxes and the boxes. These are literally just the different tiles, the coordinates of all the tiles. So the floor here is collapsed, but it's a list of all the floor tiles. We have all of the wall tiles. The targets are the green targets we want to push the boxes onto. This is the coordinates of them. Target boxes is where we have a box already on a target. There are none in this case. And boxes are where the starting places for the boxes are. So I'll show you the structure that we're going to build in the code on 2 slides. So this one and this one. The reason it's on 2 is simply because I struggle to fit it on 1 and have you not squinting at the screen. I want you to be able to see what's written here. So therefore I've split it into 2. So we're going to, when we read the data in, we're going to actually use this level layout class as our sort of parent. That's going to represent one of these level objects here, which has the tiles and then the player start. You can see here where we've used the JSON property attribute to tell C# inside there, okay, these tile layers are represented by the tiles key, or the value of the tiles key in our level data, and the player start here is represented by player start. This JSON property name attribute is used to translate the keys to the internal property names in the C# code. Now that brings across the question, of course, well, why not just name the JSON with the same key names? Well, you'll rarely get JSON where the key names are the internal format used for variables. For example, the player underscore start here would be quite acceptable if we were reading it into a Python program, but it's not acceptable for C# if you want to stick to C# naming conventions. Therefore, use these JSON property names to be able to interchange between the two. You'll notice that the type of this one here is tile layers, and the type of this one is tile coord. Tile layers is coming on the next slide, but the tile coord I have here. This again, JSON property name X, JSON property name Y, and this simply has an integer which is an X and a Y, which is represented by the 2 numbers you can see here. Also, when we get the list of tiles for our various layers, so the floors and walls, they are also the tile coords as well, but we'll have a look at that in the tile layers in a moment. We also have a utility function on the tile coord, which is just to vector 2i. So you'll notice that we have this vector2i type here. Until now in the course we've used vector2, which is using floating point numbers. The vector2i is using integers for the x and the y. With our tile maps, which you'll see later on, we actually lay the tiles out in tile coordinates, not pixels. So if we have tiles that are 32 pixels wide, let's say, and we're at coordinate, let's say 1 by 1, that's at pixel 32 by 32, but the coordinate for the tile is 1 by 1, and it's always an integer. In this case, it's a vector 2i. If you're slightly confused by that now, don't worry, because we're obviously going to dig into this when we get in the code. The main thing is you understand the tile coord is reading in these integers here, one for the x and one for the y, and I've set the JSON property names up there as well. So let's have a look at this tile layers type then. Tile layers literally reads in a list of tile coordinates for each of the layers that we have identified inside here. So our floor walls, targets, target boxes, and boxes. Then there's a utility function down here saying get tiles for layer. Here we send in a layer name. We're going to have an enum, which you can see on the right hand side here, which has our layers. And then depending on the enum, we'll just return the list of tile coordinates for that particular layer. So when we come to build our tile map, the first thing we'll do, for instance, is say get tiles for layer floor. And that will give us then all of the coordinates for the floor. Then we'll have, say, the targets. That'll get us all the coordinates for the targets, which would be these four in the case of level 1. And then we can place the tiles as we need. So this whole structure is going to be serialized in using newtonsoft.json, and it's going to be serialized into this level layout. So we're going to have one of these level layout classes for each of the levels that we have, and we'll actually have a dictionary internally where when we select, say, level 1 with the key level 1, the value that we get back then is that particular level layout class, and that contains the player start and then all of the tile layers. On the level layout itself, there is also a utility function saying get tiles for layer. That basically goes down to the tile layers, checks it's not null, and then gets the tiles for that particular layer or just an empty list of tiles. So there are a few moving parts to this. We've got three classes here, our level layout, our tile coordinate, we've also got our tile layers, and we've got an enumerated constant as well. So in the next lesson, what we're going to do is we're going to code these up, and then we're going to flesh out our game data class such that it reads all of this information in when the application starts. So we'll take a look at that in the next lesson.